So for today, I want to talk about the machine learning model. Not that machine learning model. Yeah, I mean this machine learning model. In this digital world of ours, we've obviously come across a whole lot of machine learning models. We've even interacted with them, but we don't know because we did that subconsciously. So from the outside, the word machine learning seems scary because why the hell is a machine trying to learn what you don't want to know? But this little question is what is making life easy for us right now as those living in the digital world. So in today's video, I'll be talking about machine learning, the machine learning models, the types of machine learning algorithm, and anything that is related or attached to the whole of machine learning in general. So without further ado, let's get into the video properly. Now, the first question you're going to be asking yourself is, what is machine learning? And the answer to that question is really in those two words, machine learning. It simply means you feed a machine, in quotes, a system, some data set, and it tries to learn from that data set to be able to solve problems or to be able to predict and, classify informations, classify details. So machine learning is more or less like a give and take situation. So you give the machine a data set and it chunks out a lot of solution or couple of solutions down to you. Now I'll be giving you two examples of scenarios where a machine is actually or was actually learning. Take for example when you pick out your phone and you want to type. When you type on your keyboard, you type I want to. You notice that at the top of your keyboard there is this sort of prediction right there that it can write I want to eat, you can see I want to sleep, you can see I want to go to school. Now those are predictions based on the past data that you've subconsciously fed into the model that is learning, making it a machine learning model. So since the time you bought your phone and you start typing, the phone or the software or the machine learning algorithm is studying how you type, is studying what you do, and you are feeding it in with a whole lot of data set, right? So when it gets to a certain degree, it has been, in quote, trained to know how you type, so that when you type I want to, it can help you, give you predictions that that can match what you say. Sometimes the predictions are very accurate because we really want to say that thing, and most times the predictions can be very awful. So that means the machine still needs to keep learning for it to get better to be able to predict you. Now that is a scenario of a machine learning model try to predict. Also, now the most popular machine learning models that I feel like is one of the accurate is the TikTok algorithm, and the same thing applies to the YouTube algorithm, but I feel like the TikTok algorithm is way more accurate compared to that of YouTube. When you use TikTok, you feed the model a lot of data based on how you interact with the video, how you like, how you share, how you download. For example, if a video is like 50 minutes long and you watched like, let's say 40 minutes out of that 15 minutes video, so that's like almost 80% sort of part of the video that you watch, and you liked that video, obviously you're like the average view durations are data set that you feed into the model, and the TikTok model is going to realize that, oh, this person liked this video and is going to suggest videos that are similar to that. So it gets better as you watch more videos. That way it can be able to predict and in fact classify videos for you. This time it is both predicting and also classifying videos for you, because it will predict the videos that you like, and it can also tell you that, oh, you don't like this video, you like this video. In fact, I got this info somewhere that TikTok even access your front facing camera, and then they try to map out your facial expressions to see if you are watching a video. So if you are smiling and watching the video, they can map out your facial expression and say that, oh, you are happy, and they will suggest more videos like that. And if you are not probably giving an emotion, they see it as, oh, she doesn't like this video, and try to not suggest that video to you. I don't know how accurate this information is, but if TikTok is really doing that, well, that's some Terminator level thing out there. So these are the basic two examples of machine learning. And trust me, machine learning is not just applicable in entertainment or in the social media world. It is applicable in business, it is applicable in stock, in finance, in sales, in education, in medicine and health, in economy in general. In fact, when a machine learns, it helps to ease out a whole lot of work. And in fact, machine learning is the basis of AI, which is another topic entirely. So let me try to connect a sentence to the idea of machine learning. So machine learning is the act of a system to collect data, that is the input data, work on this data, and be able to use this data to solve problems based on the specific tasks that it is needed to work on. So that is what machine learning is. And basically, we have 4 types of machine learning. Some will say 3, some will say 4, but I feel like we have 3 of them, and the 4th one is just like it's just there. So the first one is what we call the supervised learning. The next is what we call the unsupervised learning. We have the reinforcement learning, and the 4th one is semi-supervised learning. So before I try to talk extensively on the type of machine learning that we have, okay, I have to talk about what a machine learning model is. So basically, a machine learning model is actually a system that gets input data and tries to train a machine in order to solve a problem. Now, we have several types of machine learning models, and we use each of these machine learning models based on the situation that we have at hand. Sometimes it can also be based on a data set, but most times any machine learning model that you use is based on the problem that you have at hand and you are actually trying to solve. So examples of machine learning models includes the regression models, either the logistic regression model or the multiple linear regression model. We also have the decision tree, we have the KNN, we have the hierarchical clustering, we have the K-means clustering, we have naive Bayes. These are examples of machine learning models. In fact, the most popular machine learning model, and which is at least the simplest to work with, is the regression model. I think virtually everyone has worked with a regression model because it's basically one of the models that you can use to predict the value of something from another something. Now, we have basically 2 types of machine learning models. We have the predictive machine learning models and we have the classification machine learning model. So as the name implies, the predictive machine learning model, this is a model that tries to predict a value from several values. So that means you input it some data, or a data set rather, and it's going to be trying to predict a variable from the data set from the multiple variables in that data set. Now, this is very applicable in the financial market, in the business field, in the sales field, when you try to probably predict the price of a stock from several variables in the past. We also have the classification model, and as the name implies, this model tries to classify, try to see what this is and what that is. So if that is that, then you pick it. If it is not that, then you just put it out. So a typical example of a classification model is your music recognition system. Okay, so it's just 2 things: does it like the music or not? So whether on Spotify or Apple Music, if you like a music, sometimes they give you this chance to click on like and tell you if you love it. So if you love it and you click on yes, so you've given it enough data to classify and say, oh, he likes this music, and they will try to predict more of such music to you. And if you don't like it, they will not predict it. So in this case, they've classified the music based on he likes it and he does not like it. So these are the basic 2 types of machine learning model. So for a machine learning model to work, let's go deep dive. We have what we call a machine learning algorithm. So at the back end of a machine learning model, for it to be able to make the machine learn, we have some set of instructions that tells the model what to do, how to do, and when to do it. So at the back end, like I said earlier on, we have a lot of linear algebra, we have calculus, and we have a lot of advanced statistics. So the machine learning algorithm consists of mathematics and statistics that are fused in together to work hand in hand on the input data in order for it to be able to produce the solution that was intended on it. So that simply means that if you want to get into machine learning or become a machine learning engineer, then you obviously have to be very good with advanced mathematics. I'm talking about calculus, advanced calculus, linear algebra, numerical analysis, and then statistics is very important. Once you know the mathematics and the statistics, you'll be able to understand the mathematics of algorithms, and then you'll be able to build a very good machine learning model. Now that I've explained the concept of machine learning models, machine learning algorithms, and the type of machine learning models, okay, it's time for us to talk about the types of machine learning itself. So for the supervised learning, it simply means when your machine was learning, you supervised it. I think I can use the word, and that is literally it, but in a more better and well detailed way. For supervised learning, it means you labeled your data set and you tell the machine learning model what to do. You gave it an input data and you are telling it that if you see this, then map it to this. If you see that, then map it to that. A typical example of a supervised learning is a model that is built to tell the difference between a cat and a dog. So first thing first, you have to input a lot of data that describe the characteristics, the physical features of both cats and dogs. So you feed in a lot of infos about cats and dog, right? Then you now tell it that, okay, hey machine, if you see this color of eye, it's a cat. If you see this color of eye, it's a dog. You are using a specific feature to label the animal so that the model can be able to classify and say, oh, when I see this is a cat. When I see this is a dog. You can also say, oh, cats have whiskers and I don't think dogs have whiskers. So you can tell your model that if you see a whisker, oh, that is a cat. And if you don't see a whisker, that is a dog. Or if you see a pointed nose, oh, that is a dog. If you don't really see a long pointed nose, that is a cat. You are giving your machine an instruction, a set of instruction, a set of labeled instruction for it to know which is which. So that way, the data has been labeled, the input data has been labeled to a specific output. That's what we call supervised learning. You've supervised your machine. You've told the machine what to do. That makes sense, right? Exactly. Example of supervised learning includes SVM, which is the short form of support vector machine. We also have the linear regression, we have the logistic regression, we have the naive Bayes, we have the random forest, we have the decision trees, we have KNN, just to mention a few. If you flip the supervised learning, we have the unsupervised learning, which simply means that the unsupervised learning is the opposite of the supervised learning, in the sense that for unsupervised learning, you did not label your input data. You did not, in quotes, supervise your data set. You're just telling it, hey, take a data set, identify the patterns yourself, and do the labeling, the prediction, or the classification yourself. So this way, you are giving the machine the autonomy, the right to do its own thing and come out with its own results without any of the data sets being labeled. That is the basis of unsupervised learning. Now, you can tell that this is going to be more technical and a bit complex compared to that of supervised learning, right? So we basically have a couple of examples when it comes to the unsupervised learning. We have the K-means clustering, and we have the hierarchical clustering. I think I got that right. Now, the semi-supervised learning is just a mixture of the supervised learning and the unsupervised learning, in the sense that you actually have an input data and a part of this data set is labeled and some parts are not labeled, and then you put this into the machine learning model. So that way, it's going to be giving you both labeled outputs and unlabeled outputs. So it's just a combo of the supervised and the unsupervised learning. Now, when it comes to the reinforcement learning, now this is a model that trains itself and it just does its magic itself. It has nothing to do with you supervising it. All you have to do is just give it data and it's going to train itself, and in the long run it gets better. Because this model trains itself without any form of supervision or label data or anything, it means there are going to be a whole lot of trial and error in this sort of scenario. So let's assume you gave the data set and input data and you wanted to classify dog and cat. So you gave it the data set, this is a dog, but the model mistakenly classify it as a cat. So what do? You give it a feedback and tell it, no, you are wrong. this is a dog. So it will learn from that feedback and in the long run get better as classifying a dog as a dog and a cat as a cat. So like I said earlier on, this is more or less like a try and error sort of models. It keeps making mistake, it keeps working, and in the long run it gets better at classifying or predicting anything that you want it to do. A typical example of a reinforcement machine learning is the self-driving cars, the autonomous machine. You see, for a self-driving car to be able to drive itself, rather, there must have been a whole lot of trial and errors. There must have been a whole lot of cars that have been damaged, like a whole lot of self-autonomous car or autonomous car that have been damaged for it to be able to like walk through the road, because a lot of things have to go wrong for it to get it right. So for example, the car may hit an obstacle today and they have to like reprogram it and tell you that, you know what, when you see this shape, this height, this thing, try to move away from it, and you walk from there. And it goes, it sees an obstacle, it moves away, and then it's beating the red light because there was red light, it saw the red light, but it moved, it was green. Also, then you have to like remodel it and retrain it that if you see a red light, you stop. If you see a green light, you move. If you see yellow light, you get ready. So a lot of trial and error keeps going until the machine or the car gets it right. These are the 4 types of machine learning. Now, a machine learning engineer is basically someone that knows how to use the right machine learning model in the right situation, and also knows how to like build a machine learning model and understand the concepts of machine learning algorithms. So these guys are, they are paid heavily well, but you know, it's for someone that have interest in solving problems, building things, and also at the same time the person loves mathematics, statistics, you know, advanced calculus and all of those things. So if that sounds like something that you like or something that you want to, so you can obviously try to get some course from Coursera or, you know, some of these Udemy courses and the likes, just to get into machine learning. So this is the basis of machine learning and machine learning models and algorithms and the types of machine learning models. I hope I've been able to make it as simple as possible for you. So if you learned something new from this video and you enjoyed this video, please don't hesitate to give me a thumbs up and also subscribe to this YouTube channel. Do you feel like I missed something or you have some questions for me? Please don't hesitate to go down to the comment section and drop your question. I would be willing and be ready to, like, you know, attend to all of your questions. Thanks for making it to the end of this video, and if you want to know how to analyze a data set as a beginner, I have a video right here for you that you can actually check out. It's a very interesting video. And if you need a statistics playlist for your data analysis journey, I also have a video right here that you can actually check out. We'll see you in the next one, and bye for now.